Welcome to Thursday of week 8 for Level C Math. We started not recording some games with winning strategies. We played the 1 over 1 house, 1 over 2 houses, and 15 a few times. Now we're starting homework questions since we've had our brain warmed up. The other announcement was there is a spreadsheet that'll share in the after class email about all of the Level C Math topics and how they relate to our syllabus or the Moodle shell for the class that Minu made, or our website that I made, or the state standards for Level C, or the GED topics. So you don't have to look at this, but if there's some way that this helps you figure out, I want a little more of this, this seems the thing I am shaky about, and I would feel better if we had more before the term is done, then that's one thing you can do. You could also, of course, just look at the table of contents for any of our 3 main topics, the shape-shifting, the mad science, or the justice, and say, that was one I want more of. And then a reminder that the other things, these 4 at the top, those are kind of extension projects, and you are more than just a GED preparer. If you have some interest in food or saving or retail or something, then these are ways to bring your real life interests into the math class. Let me know what you would want to talk about. Okay, but for now, homework questions. And so this was from the order and terms, which is part of squishing things together, mad science. So order and terms, the random exercises, random exercise G as one of these things. Okay, where are my terms? I'm going to start going, try not make it wiggle. So where does this first term end? There, yeah. Where there's a plus or a minus outside of parentheses. So that's all one term. Okay, 8. And that's it, because that's a plus or minus outside. And 6 is also its own thing. And then all of this is the last term. Everyone okay how those 4 terms?
Yes.
So this plus or minus is just going to continue as we simplify things bit by bit. And this term is completely independent of that term. We sort of normally work from left to right just because we're used to that. But if I wanted to fill in the 8 and the 6 all the way down, I could. They're independent from the other terms. Okay, let's approach this term. How do I start making that first term simpler?
4 times 12 is 48. So 4 plus 48.
So let me talk a little more. You did perfect. Maybe you are thinking about PEMDAS. Realizing that multiplication and division are actually one thing with the same priority left to right, and so are addition and subtraction. And if you're thinking that way, then you would do multiplying before addition. Or maybe you were thinking within that parentheses, then the 4 is a term and the 12 times 4 is a term. Both ways of thinking get you to the same thing, where let's put the 12 and the 4 together first. 12 times 4 is 48. And then indeed, the next thing to do is 4 plus 48. Okay, we're almost done with that first term. 3 times 52. So what's 3 50s?
150.
150, and then 3 2s is 6 more, so 156. Okay, and on the last term, 81 divided by 3 cubed times 2 to the 4th. Let's get rid of those exponents. So what is 3 times 3 times 3?
27.
27. And then what is 2 times 2 times 2 times 2? That's a lot of 2s.
16.
Okay, now we have only multiplication and division. So we'll go left to right. 81 divided by 27. If you need to use a calculator, that's fine.
Yeah, I did.
3.
3. And then 3 times 16.
48.
And now I'm ready to finish. I've changed each term into a single number, and now I just kind of can add and subtract. So 156 plus 8 minus 6, that's just going to be plus 2. So I'm up to 158. And that will make it 198. And then 8 more would be 206, unless I made a mental math error because it's late. Let's check our work, because of course the fancy calculator can do it all in one thing. So 3 times parentheses 4 plus 12 times 4. Then it was a plus 8 minus 6. And then plus 81 divided by 3 cubed. And then times 2 to the 4th. 206. There we go. This would actually look even clearer if it was one that would let you see a division sign instead of making it look like a fraction. This is a little obscure, but I will put it down there just so we have it for archives. Okay, questions about this one now that it's on the board?
Is cubed always to the 3rd power?
Yep.
Okay.
Yep, the little exponent tells you how many times the bottom number is multiplied by itself. So 1, 2, 3 because of cubed, 1, 2, 3, 4 because of to the 4th.
So the 4 is cubed also.
The 4 doesn't really have a name. So if I want to draw 3 squared, I can. That would be the area of something that's 3 units on a side, 3 feet, 3 inches, something like that. And I can say, that's 3 times 3 is 9. And there they are, 9 boxes. If I want to draw 3 cubed, then I would have to say, let's take one of those that we just drew and make it into a 3-dimensional shape. And if you chopped that up, and you could build one with sugar cubes if you happen to have them at your house, then there would actually be 27 cubes in that thing.
Okay.
3 to the 4th, I can't draw a picture of that. I can't build one with sugar cubes or blocks or paper squares or something. So no one has really bothered to make a name for it the way 3 is cubed and 2 is squared, because this is a square and this is a cube and that's a hypercube. But yeah. Let me email Brandy real quick because of her volume not working. So a wonderful question. 3 to the 4th certainly means something. 3 times 3 times 3 times 3. We just don't have a cutesy name for it. Okay, other homework problems. I know some people did from the justice topic.
I had trouble with a couple of them on the measurement.
Measurement, 10 exercise. Okay, let me make it bigger. Let me put that in the window you can't see so I can make it narrower for copying and pasting. Okay, pick which one and we can do it.
Number 4.
Number 4. Okay. This is a tricky one. I gave a hint last time of just drawing what the picture was. So we're going to take a circle and then we're going to make dotted lines. So there's the middle of our circle and it's in 4 equal parts. The radius is 6. Which line should I draw for the radius?
The one on the right.
One on the right, yeah. It doesn't matter at all. Any of them that start in the middle and go towards an edge, that is 6 centimeters. It's had the southwest corner removed. So the part we want doesn't include that. Let's see if I can do somewhat respectable artwork here. So this is the shape that we want. And a very common mistake is to notice that the bottom corner that's removed looks sort of square. But if you try and do a circle minus a square, that's not going to work because you're going to erase this part of the square with your subtraction that wasn't there before. You're removing too much if you remove a whole square. So if you started on that since Tuesday, then don't feel bad. That's a mistake lots of people make, but that is the wrong way to do this one. How should we do this one? Any ideas?
Divided by pi?
Well, we can find the area of the whole circle.
Yeah. The circumference then.
Yeah. Oh, I'm doing area. Yeah, you are right. I am wrong. We want the perimeter. Thank you for catching me. Okay, perimeter. The area one is from one of the practice tests. So the perimeter of the whole circle all the way around. Let me draw this then too. So we don't want what I shaded in green. We want the perimeter. So we want the red thing, the trail the ant would walk. So the perimeter of the whole circle is what?
Pi times diameter.
Pi times, yes. So pi times, and what's the diameter of this circle?
12.
12. Everyone see why?
Yeah.
If you went from here all the way across, that's 12. Because halfway was 6. So pi times 12, which is about, pi times 12 is about 37 points. Okay, that doesn't quite help us though. We don't want all the way around.
Divided by a quarter, 0.25.
Yeah. We divide it by 4. Then we get about 9.4. So where is that on the picture? That would be 9.4 centimeters is that much, right? 1/4 of the way around. So we have one of those. We have another one of those. We have a third one of those.
Oh. So 9.4.
Times 3, we're up to about 28.8.
Right.
We also need to go up here and up there to finish our path.
That's another 12, isn't it?
Yep, because this is 6 and that is 6.
I could be wrong, but I think you rounded that wrong. I think it should be 28.3.
Maybe. Except I'm not rounding in the middle as I go. The calculator is actually keeping going. So
I just meant from what you okay, never mind.
so if I had done next line 9.4 times 3, then yes, it would be 28.2. But I don't want to round in the middle. As long as the calculator will let me just kind of keep going, then I will.
Yeah, but wouldn't it still be 28.3 because it's 28.27?
Oh, yes, I'm sorry. You are right, I am wrong. Okay, so then we add 12 to it. And we get about 40.3. Thank you for correcting me. Oops. Okay, yay, I'm sorry I messed up and shaded the area. I am too used to the problem. That's exactly the same, but it asks for the area.
So the perimeter and the circumference is the same.
Yep, the perimeter and the circumference are the same. That was going all the way around. And then you did the right thing of saying, let's just look at 1/4 of it instead of all of it. And then you could put that together 3 times and then have the little straight line bits too. Should we do another similar one?
Sure.
Let's see what we have for perimeter on the random ones. Oops, yeah, this was the one I was thinking of. Let's do 5. I'm going to remember to change the number this time, so I'm not doing your homework all for you. Let's make it 12 feet. So a half circle window. Do I have a half circle? I do. Has a diameter of 12 feet. So what's the perimeter of that window? So the whole circle circumference, perimeter, whatever you want to call it. How big is it if we wanted to actually go all the way around the circle?
.14 times diameter.
Mhm. So about 37.7. And again, keep hollering when I do it wrong. Okay. So what is just this part?
Well, you divide it by 2.
So now we're about 18.8. 8. And then we want to do that part.
Well,
Yep, that's just 12 going from here to there. Ta-da.
Could we also look at 6 and 7, please?
Sure. Oops. Okay. I'm going to make the diameter instead of 30. Let's just make it 40, so I'm not doing your homework. Okay, so my picture isn't to scale, but I have something like this where we have a swimming pool. Imagine this one has water in it. And this one is an area problem. I am remembering to look carefully. So for area problems, do we want radius or diameter?
Radius.
Radius. So for one of them, I have this radius. And for the other one, I'll have a slightly bigger line. So how big is my blue radius for the inside circle?
20.
20. It was 40 all the way across. So half must be 20. Everyone okay with that one? This little extra bit here is 2. We want a 2-foot wide sidewalk going around. So what's the green radius?
22.
22. Everyone okay with my picture?
Yeah.
So how much area is the sidewalk? How would I find that?
Pi times r squared. Or r times r.
I don't want a formula quite yet. So I just want kind of a description, a plan. I want to get just this donut between the two circles. Can you-
44-foot diameter?
You're still jumping ahead to the lines down here. I just want something about the circles as like my strategy, my plan of attack. Am I adding things? Am I subtracting things?
20 foot plus 2.
20 feet plus 2. Well, we do need the area of the big circle,
Okay.
right?
Uh-huh.
So I can put that down, area of the big circle.
Subtracted by the pool.
Yeah. And then we're going to subtract the area of the pool, the small circle. Imagine that we rolled out cookie dough. It's as big as the big circle. And then we have a round cookie cutter and we're going to punch out the middle. And what's left is this donut we want.
Oh, okay.
Does that make sense?
Mm-hmm.
So for all of these sort of area puzzle problems, and you could even do it for the perimeter if you wanted, make sort of a plan first. Don't jump to the equations, don't jump to the formulas, don't jump to the numbers, but figure out what you're doing. For this one, we could have said that this path is that much plus that much. And then this was half of pi times diameter. And that was 12 and kept going like that. Does that make sense?
Mm-hmm.
It's often easier to sort of make a plan that's just a picture-y kind of plan before you work with the actual math. Okay, but you've already told me that the area of the big circle is pi times r. And that's what the area of the small one is also. So pi times 22 times 22 is about 1,520. I'm not putting a decimal on this time. You certainly could, but I figure this is like a real life thing with concrete. So I'm probably not accurate to the 10th of a square foot. Maybe you are better at concrete than I am. And now it's pi times 20 times 20. So 1,257. I guess this one I should have rounded up to 1. I am not passing my rounding test today. Okay, and 1257. Okay, everyone okay with what we have so far before we finish up?
Yeah.
Okay, so what is that? 1521 minus 1257 gives me about 264.
What just happened? Where'd the 1257 come from?
That was pi times r with 20.
Oh, right.
That doesn't look right, did I? 1521. Okay. Questions about number 6?
I'm good now, thank you.
So now we wanted number 7. Okay. So we have 2 pizzas. I'm not quite sure which is bigger yet. We can adjust the picture in a moment. One of them is 20 inches diameter. So all the way across is 20 inches. The other is 40 centimeters diameter. So that's hard to compare. They're not the same units. It gives me the conversion rate. 1 inch is 2.54 centimeters. Which one do you want to switch out? Do you want to make the inches centimeters or make the centimeters inches?
Centimeters to inches.
Centimeters to inches. Okay. So first, we have 40 centimeters is so many inches. We've seen 3 different ways to do this. There was thinking about multiples or factors. There was the goes with chains. There was unit analysis. How do you want to do this one?
Unit analysis.
Yes, okay. So we're either going to divide by 2.54 or multiply by 2.54, but it's late at night. We're taking a test. We're worried about something outside of math, whatever. We want to find the fail-safe ways so we don't have to think, are we multiplying or dividing? So start with what they give you, 40 centimeters. Is it a fraction? No, put it over 1. And then I want the centimeters to cancel and turn it into inches. So we'll put the 2.54 with centimeters and the 1 with inches. Why does this work? Remember that the top 1 inch is the same as 2.54 centimeters. So this is fraction where the top and the bottom are the same thing. It's just a fancy way to write the number 1. Because any fraction with the top and bottom the same is 1. Then once we have inches, our goal, we can multiply across the top and bottom. And so it tells us, oh, you're supposed to divide, because our last step of unit analysis is always top divided by bottom. That's how we turn fractions into decimals. So 40 divided by 2.54 gives me 15.748. I'm going to write lots of decimals because I'm not done with my problem and I don't want to round in the middle. Okay, yay, I will erase that. And I will say that it is a little bit smaller. And 15.748 inches. Okay. By the way, the blue pizza cost $18.99. And the green pizza costs $14.99. So which one is the better buy? Is this a perimeter problem or an area problem? Which is the better measurement for how good a deal we're getting on pizza?
Area.
Area, yeah, I want to look at how much space is taken up by the whole pizza. How much space is taken up by this pizza? So I want to do area for these. Okay, so area for the blue one. You've told me the formula already, pi times radius times radius. The radius is
10.
n. So that's going to be about 3.14 with zeros scooted twice. And the area of the small pizza has the same formula. Now we need to do half of our 15.748. So about 7.874. So we want pi times that answer is about 195. Now I am rounding to the nearest square inch because this is pizza. Pizzas aren't perfectly circular. I have worked at a pizza shop before. That was a great summer job in one of my high school years. Okay, so we know the areas. How do we know how good a deal we're getting?
Oh. Price divided by area.
Sure. So price $18.99 divided by 314. So it is about 6 cents per square inch. Remember, division is per, so we're doing money per square inch. And the small one is $14.99 divided by 195 square inches. 14.99 is about 7.7. So like 8 cents per square inch if I'm rounding. So there we go. This one's the better buy. 6 cents per something is cheaper than 8 cents per something. Questions on that one?
I'm good.
Did anyone divide the other way? You certainly could. You could say, let's take the square inches and divide it by the price. If you did that, you'd get a different measurement, not how many cents do you pay for one little square inch of pizza. Imagine a square cookie cutter, and for some reason you were buying it one square at a time. If you did it the other way, you would be doing square inches per dollar. It was like each of these was chopped up into $1 slices, which $1 slice was better. So then you would get it different numbers, of course. And it's true that the blue number, the big pizza number, would be bigger. You're getting a bigger wedge for $1. So you would still agree that the big pizza is the better buy, but if you divide things in the other order, you would want the bigger of the results. If that doesn't make sense to you, don't worry about it. But I want to explain that for the people that started with those numbers. Okay, other homeworks? Did I forget to change the number on that? I did. I did your homework for you. Oh. No other homework questions yet?
I'm good, thank you.
Anything for percentages or fractions? So at this point in the term, besides homework, you should be doing all of the tests at the end too. So go to each of these 3 topics we've done, go to the test at the end and say, can I do this? Check my work. Maybe reload another one, check my work. Okay, that's good. I'll go to the mad science test and do that, check my work, and so on. So your goal is by finals week, because the final is just these put together, right? Math 20 overview. I should also rename that level C overview. That's just all 3 of those put together. Very familiar. So try those and see. Bring homework questions and practice test questions starting next week. And in fact, I will just change that right now. That's rude to call it Math 20 when we're level C.
For the final, are we able to use our notes?
Yes. Okay, now it says level C and math 20 overview. It is not prejudiced. When you actually click on it, it will say the same thing. So, yay. Okay, let's talk more about typicality since we have a few minutes. This is stuff that you've seen before about bar charts and frequency tables and things like that. Some of it we're going over just because of the jargon. Maybe you don't know the phrase frequency table, even though I'm sure you've seen them before. And if it shows up on the GED, you want to know what the words are about. And maybe we're just thinking about them a little more carefully than you have before. So we're going to do the first few parts of picturing data, and then that'll be all for tonight. The other GED thing that you will care about is words about averages, mean, median, and mode that you've heard probably before, but again, we want to look at them more carefully. Everything else in the typicality chapter about bell curves and probability, we don't have to do. If you want to, we can. We have 2 weeks to do whatever you want, but that's officially stuff that you will mostly see in level D and E. And if we get to it, great. If we don't, that's fine too. You want to take a 5 or 10 minute break to deal with kids and warm up drinks and get a bite to eat before we do some typicality?
Yes, please.
Okay. 5 minutes, 10 minutes?
5 minutes works.
5 minutes. Okay, see you in 5. Typicality. So typicality should be easy, at least the parts we're doing. If it's not, then you're making it harder than it should be. So don't keep charging forward, but ask questions, figure out what you're doing that's making it bigger than it should be, harder than it should be. Because these things are things you've seen before, or they're just a new setting for the same type of math we've already done with percentages and stuff. Typicality is an interesting topic because we have a lot of different English words for what typical is, and they're not very precisely defined, and people lie with statistics a lot, and we can have genuine arguments about what is typical in a certain situation. So we'll get to more of that next week when we talk about averages and ambiguity and words about averages. But as a preface, we're going to talk about just picturing data in different ways. And we're not going to get through all of this right now, but that's okay. So when we're picturing data, then we could draw a picture. So here is a picture, and you will see that this picture is not really helpful. Somebody decided to ask their elementary school students what kind of animal makes the best pet. And set things up better, actually. Okay, typicality, picturing data. There we go. Each student was allowed one reply. So it's not that there actually was a green dress girl that shouted 5 things. These are 5 different students that had their answer. And the teacher wanted to be cute and made this cute picture with all of the images there. And this is very awkward to use. If I want to say how many students picked cat, then that's hard on my eyes, but we can do it. How many students picked cat?
3.
3, let's see. 1, 2, 3, 4, 5. We had 5
You
students.
missed one on the yellow.
Oh, no, you're right, I did. 6 students picked cat. Okay,
Wait, what?
because each word is one of the different students in the class.
Oh,
Okay, this picture represents 4 different students that picked cat, 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 and unicorn.
gotcha.
So this was a bad way to picture the data. It doesn't help us answer these kinds of questions. What could we do to be a little more clear? So we're going to do these things called a frequency table. So here is a frequency table for this same data. And oh my goodness, this is so much better. Somebody has gone through and counted that there were 6 cats, 3 fish, and so on. And now we can actually answer these questions easy. How many students picked cat? There's 6 of them, right? There we go. It's not as cute and colorful, but it's much easier to work with. Notice these tables have to have 2 columns. One is what categories are you working with? And then the other is how many times that thing appears. Everyone with me so far?
Yeah.
Yep.
Okay, ta-da. I also make a joke that the clip art wasn't very multicultural. The table circumvents that. So we could look at this table. I'll just do it here. How many students picked 4-legged animals?
$11.
11.
I got 13.
So 4-legged, that would be the cats, the horses, the dogs, and the unicorns. So the 6 and the 4 is 10, plus 2 plus 1 is 13. Slightly tricky, but that would be a nightmare if we were trying to use the picture instead of the frequency table. We could ask a different thing. What fraction of the students picked 4-legged animals? It's 13 out of something.
21.
21, we'd have to add up everything, right? Often a frequency table will have something at the bottom that says total. We could ask what percentage. How would we change the fraction into a percent? Don't make this harder than it is. You've done this a bunch. Fraction to percent.
Would we divide and then do ripple up?
Yes. 13 divided by 21. So it's about 0.62. So 62%. If you wanted, I can draw the wood block right into percent. Okay, everyone happy with these?
Yeah.
Okay, I have a sudden urge to rotate my frequency table 90 degrees counterclockwise. And now I'm going to put little fancy colorful squares. So the cat was 6, so it has 6 squares. The fish was 3, so it has 3, and so on. And this is ugly. You would never actually write that, but you can see how it turns into this bar chart. So this is a third way to represent the same information. And with the bar chart, we could ask the same questions. How many students picked cat? 1, 2, 3, 4, 5, 6, because that's how tall that bar is. How many students picked 4-legged animals? You'd add up the 6 for cat, the 2 for horse, the 4 for dog, and the 1 for unicorn. Some bar charts decide to be extra polite, and at the top of each bar, they will write what the number is, just so you don't have to move your eyes to the side and look it up. That's optional. Many frequency tables have that total at the bottom. Bar charts don't. There's really no good place for a total, but you could still add up all the numbers if you were wanting to find the total, because somebody asked you about the fraction or the percentage. So far, so good?
Yeah.
Okay. The last thing that we're going to mention, and I don't have a cute thing here, but I will soon, is a pie chart. And I would love it if we were all in person, because I would have you do this little thing with scissors. You're welcome to try this at home. I'm going to take a circle and put a dot in the middle of it. And I want to draw a bar chart, and I'm going to cut out all the bars. So I will have the bar for cat that's longest, and the bar for fish that's half as long, and the bar for bird that's almost as long as cat, and the short little bar for horse, and a bar for dog, and then a very narrow little bar, I'll use green again, for unicorn. And I'm going to tape the bars after I cut them out together to make like a train or a caterpillar or something. So imagine I've put little pieces of Scotch tape. Everyone with me so far?
Yes, sir.
Yeah.
Then I'm going to pick up my train, pick up my caterpillar, and tape this end together with that end. So I have a ring. And if I look down at it from above, maybe it's bigger than my circle on my paper, maybe it's smaller, but it's something like, there's the cat piece of paper, and then the fish one, and then the bird one. Oops, bird was yellow. And then the horse one, and then the dog one, and then the unicorn one. Because I've taped together these bars that I physically cut out of my bar chart, and I made a ring out of them. Everyone with me so far?
Yeah.
And if I centered it, then I could draw lines from the middle through all of the connecting spots. Oops, that was a bad line. And then that's how I make a pie chart, because this big one that was blue was the cat part of the pie. And this green one that was the fish was the fish part of the pie, and so on. It makes them all the right sizes compared to each other. And you've seen pie charts before, I am sure, in real life. So those are our 4 basic ways of trying to describe data. We could make some sort of cutesy picture, and there are plenty of people that make a living making pictograms and infograms and things like that that are better than this one. There's a frequency table where we have 2 columns, what there is in each category and how many. There's a bar chart. It's easier to see the comparisons, slightly harder to find the total. And then there's the pie chart where you can kind of, I don't know, pie charts don't tend to be good for much. We'll talk about that later. Okay, questions so far?
I'm good.
Okay, let's go back to where we were. So a bar chart compares the frequencies of several unordered categorical data types. So unordered means that we haven't sorted them. Cat happened to be the biggest and first, but there's not any particular reason we picked cat first. A Pareto chart goes from tall to short. It's just a fancy name. I have no idea if Pareto charts are on the GED. I don't think so, but just in case, there's another vocab word for you to put in your notes. The next thing I want to do, let me shrink this a little so it looks better on the Jamboard, is say, what if I was trying to give a business presentation about all of this for some reason? Then we had found out earlier that 4-legged animals were 62%. We did part divided by whole, and then the riplop. We could do the same for each of the categories. We could say that cat is 6 out of the 21. So that's 6 divided by 21. So it's about 29%. And we could keep going for all the other rows. I'm not going to just do the same math 6 different times, but it might be polite if we're presenting this to other people to do all of these numbers for them. So if they needed to use them, they wouldn't have to find them themselves. So this is called a frequency chart. It doesn't get its own special name, but it now has 3 columns because we've put in an extra column with the percentages. And before we just said frequency, but now we want to be a little clear. Is this the counted frequency? We actually had 6 people say cat and we counted it. Or is it the relative frequency, which is the fancy jargon for the percent that goes with it? If you want, you could still do a total row. Maybe that would help you if you are making this presentation to people. Questions about this one?
No.
Everyone could add this extra column if you wanted to, if all you had was the first 2 columns.
Yeah.
So why would we care? Let's say, for example, that this elementary school class that did the survey wants to share a morning pet fact at the start of each school day. In that school term, there were 80 school days. So how many days to sort of fit this chart, be fair to the students' votes for what they're interested in? How many days of the 80 should have cat facts? How would you answer that question? We know that cat went with 6 or 29%.
$23.2.
What did you do? How did you get your answer?
29%. No. Yeah, 29% times 80.
So 29% of 80. So change that back into 0.29, ripple up the other way. Of becomes multiply. And yes, 0.29 times 80 gives me 23.2, so about 23 days. Other people might say, Cheryl likes percents, but I like cross multiplying. So what I would do is make a proportion. 6 out of the 21 votes, that's one situation, should go with a certain number out of the 80 days. That's the other situation. So 6 cats out of 21 total. Y cat days. Actually, let me start over and write this better. It's 6 cat votes out of 21 total votes would be, I'm not sure how many cat days out of 80 total days. So we should be able, with a proportion, to label it where one situation is on one side, the other situation is on the other, and the same type of thing is measured on the top, and the same type of thing is measured on the bottom. And yes, if you solve this, you would also get about 23. Everyone okay with that?
Yeah.
So we like relative frequencies because we can generalize from one situation, students voting on what pets they want to talk about, to other situations, like how many morning pet facts should we have? We could view the relative frequencies as scale factors if you like doing that. So that's all of this first section about frequency tables and bar charts and a hint of pie charts. Okay, more jargon. We can order our categories with the pets however we want. We could do it alphabetically. We could do it biggest to smallest. We could do it in the order the students called things out. So we call that categorical data, where we have different categories and they don't have a particular order to them. Some categories have a little bit of variety, but there is certainly a most natural way. And the jargon for that, which you will probably never need, but I'm showing you anyway, is ordinal data. So grade levels at a certain elementary school. It might be that if you were looking at how much they earned at a certain fundraiser, you wouldn't put them in order and go from K1 to all the way up to either 5 or 6, whatever your elementary school had. Maybe if the 4th graders earned the most money, you would put them first on the chart and order it by money. But normally when you're thinking of grade levels, there is a natural order. So we would call that ordinal data instead of categorical data. And finally, we have numerical data. If you wanted a chart of what did people get on a test score, then yeah, you really have to have the low scores on one side and the high scores on the other, or everyone's going to look at you strange. So if we have numerical data and we make a bar chart, that's called a histogram. And so you might have seen something like this. This was one from one of my old classes where students took a midterm. A few students got these very low blue scores. A few students I colored orange. They're in the middle. There was a nice sort of hump of yellow bars. 3 students got an 86. 2 students got an 88, and so on. And then a few students were way up at the top. They really knew what they were doing. It might make sense in this class, depending on the syllabus, to say that the greens are A's, the yellows are B's, the oranges are C's, and the blues are D's, or something like that. It depends on what you would be asked to do with this data. But on the bottom of this, we just have the numbers in order because it's numerical. It doesn't make sense to do them in any other way than start at the small and go to the big. And the bar chart counts how many on the up and down axis. Everyone okay with that?
Yeah.
Now looking again, I don't have the number 87 on this. Each of these things on the bottom is actually 2 numbers, like 85 and 86. So these 3 students on the tallest yellow peak, maybe they got 85 or maybe they got 86. They are clumped together. So these groupings on the bottom are called bins, like you're putting physical objects into a bin to sort them. And an interesting thing about histograms is if you make your bins different sizes, it looks different. So this is exactly the same data set, but now my bins are grouped by 5s instead of by 2s. No longer does it look like there's the biggest B group. Now it looks like this kind of B plus A minus group is the giant one. So there's a saying, there's lies, damn lies, and statistics. Part of the reason why it's easy to lie with statistics is you can do it even accidentally. Just by picking how big the bins are in your histogram, it will change the shape of your data. It might change what grade you give a student. It might make something look like it's a big deal or not a big deal in politics or economics or something. Okay, and applications of relative frequency. Yeah, we did that one. I need to sort things a little better here. Okay, so that's as far as I want to get today. This is a topic that doesn't have any homework for it yet. I'm still building it, but that's the kind of thing that you'll see on the GED. And I don't know if they will ask you which of these things is a frequency table, but now you know the names just in case they do ask you that. Certainly the takeaway is, can you take a frequency table without the relative frequency and add that column if you had to? That might be something you're asked to do on a GED. Questions about any of that?
I think I'm good.
Okay. How much of that was brand new to people? Let me turn off the recording.